Assalamu alaikum students. Today we will study a couple of different plots which can be used to graphically represent data in different forms. First of them is stem and leaf plot. It is a very simple way of representing data. This is not a usual type of graph or curve or plot. It is a way of representing or displaying data in which the displaying of numbers which are more interpretable and more understandable. So to construct stem and leaf plot, we divide each number into two parts. Very simple. We have a number and we divide it into two parts, and those parts are called as stem and leaf. First part is stem and the second part is called leaf. The stem is the digits of the number which are the leading digits, or the first digits on the left side of the number. So the numbers on the left side, or the leading digits, are stem. Divide we call them stems, and the ones on the most right hand side are called as leaf. um, for example, if we have a number 45, we can divide it into a stem and a leaf. Stem will be on the left hand side, means the ones which are the leading digits. Leading digits are the ones on the left side, and the trailing digits or the remaining digits are on the right side. We can divide it into two parts like this. 4 will be called as stem and 5 will be called as leaf. Similarly, if we have a bunch of data, we have a few numbers in the data set, we can divide all of them into stems and leaves. Let us take a look at an example. This is a data set which is actually the cycle time in days to pay employee health insurance claims. So this is the cycle time means the time that takes for a certain task or a process to complete. So this is the task that is completed in days, or the cycle time to pay employee health insurance claims. The employees which claim their health insurance, uh, they apply for it, and then once they get the money, the process is completed. So starting from application until completion of the claims is the time that is given here in this table in days. For example, claim number 1 took 48 days to complete. Claim number 2 took 41 days to complete. Claim number 3 took 35 days to complete, and so on until claim number 40. It took 17 days to complete. So in total there are 40 datas. Okay, so the data for, or the cycle time for 40 health insurance claims. Now we will try to represent it in terms of stem and leaf type of display of the data. So in order to do that, first we need to know what is the smallest number in this and what is the largest number in this. So the minimum value that we can see in this data is 16, and the maximum value is 56. So once we have known that, now we need to uh, list down the possible stems, and then we can find out leaves to connect with them. So the stems are from starting from the minimum value to the maximum value. The smallest stem is 1 and the largest stem is 5. How? The minimum value was 16, so its stem, the one on the left hand side, the leading digit is the stem, and the trailing one, or the on the right hand side, the last digit is the leaf. So this one is the smallest stem, and the one with the maximum value or the largest value in the data is 56, means that it has stem 5 and leaf 6. So stem 5 is the largest stem in this data set. Now there are two ways to represent it. One is like 1 2 3 4 5 as it is, and the other way is we can divide them into two parts. Each stem can be divided into two parts, like 1 1, 2 2, 3 3, 4 4, and 5 5. Why? Because like this, by doing so, means by dividing them into two parts, we can have an easy representation of the data. So the first one, like if we divide 1 into 2, 1 and 1, the first one will contain leaves which are less than 5, means 1 until 4, and the other one, the second one, will contain leaves from 5 until 9. How? Like this. Now we divide them into 2, 1 1, 2 2, 3 3, 4 4, 5 5. Okay, now we will go through the data, and one by one we will write leaf in front of the stem. The first digit, for example, the first number is 48, its stem is 4, and its leaf is 8. So we will go to the stem 4. There are two 4s now. Now we have to look at the leaf is 8, so we will go to the second one because it is greater than 5, means it is in the upper half. So the upper half is here, the bottom one. This one will contain from 0 until 4, this one will contain from 5 until 9. So this one, the 8 goes here, so 8 goes here. Then the next one, again the stem is 4 but the leaf is 1, it should go on the upper one here, so like this. So these are written like means in not means in the straight line, because we want to write them in this in ascending order, smaller here and larger here. Once it is whole completed, then you will see the trend. And then similarly, next one, we go to the next stem number 4. It is stem is 4 but the leaf is 6, we write it here. And then the next 4 is 4 stem and 7 is leaf, it will go here. And then next one is 4 2, means it is in the lower half, it will go here, 2 will come here. And then next is 46, 4 is stem, 6 is the leaf. Sorry, there is 43, this one I missed it. So this is 3 is the leaf, we will come here. And similarly we will go through all of these with 4 stem 4, and we will write all of them here. So by doing this, we have completed the leaves for stem number 4. We'll go you can go through all the data set, means all of this table one by one, and write leaves in front of the stems, and you will get this thing. You will get this thing here once this table is completed. Here this one is missing because there was nothing, actually this one should have been here. So there was no number below 5, so there was no leaf below 5, it is not written here. And similarly here there was no number below no leaf for stem 5 below 5, that's why it is empty. Now we can add one more thing in stem and leaf plot, that is the aggregate. We can write this thing like this. So what does it represent? It represent the number of leaves in this list. So first there are 3, 1 2 and 3, these are 3 leaves here, it mentions 3. The next one aggregates the leaves on this stem plus the previous ones. Since there is no leaf here, it is 0, so 0 plus 3 is 3. Next, in this stem there are 1 2 3 4 and 5 in this, and 3 previous ones. How many are these now? 8 plus this 5 plus 3 are 8. Okay, so 1 2 3 4 5 6 7 and 8, these are the 8 leaves in this until this stem. And similarly we go to the next one, 1 2 3 4 5 and previous 8 are 13, right? And this one, the one in the bracket, this one represent the actual number of leaves on this is the middle one actually. 1 2 3 4 5 6 7 8 9 10, this is the middle one. 1 2 3 4 and fifth one. So on the fifth one, it is not aggregated one, but it is the real number of leaves here: 1 2 3 4 5 6 7 8 8. So that is why it is represented in the parenthesis, that it is not the aggregated one, but this is the real number of leaves on the middle stem. This is the middle stem. It divides the data into two halves, upper half and lower half. Okay, now we go towards, after this we go towards the bottom side. So now here we will not aggregate from here, we will start aggregating from the bottom. Earlier in the lower half we started aggregating from the upper side, and here we will start to aggregate from the bottom side. Here it is 1, there is 0, it will means it will stay 1, and here 1 2 3 4, it should have been 5 here actually. Okay, so and then 1 2 3 4 and this aggregated one, and then we add all of these together and it becomes 19. So this aggregation on the bottom side starts from the bottom, and the aggregation from the in the upper half starts from the top side. Okay, and the middle one is the real number of this is not the aggregated one, this is the original number of leaves here, and it is represented in parentheses. So this aggregate portion is not uh, compulsory, but it is good to have if you want to extract more information from the data. Now the advantage of this type of representation, because this tabulated form is one way of representing data, right? This is another way of representing the same data. Now, this one will give you a better understanding of what the data looks like, what is the distribution of the data, which part is the middle one. So if we want to find out the median, we will immediately know that the median lies in the middle stem, here in the middle part. So the median lies in this stem, so we can calculate that and we'll find out that it will actually lie in this part. And we can also see that which portion of the data has more numbers. Like this one, we can see that there are more numbers in this region and very few numbers on this and very few numbers here. So most of the data is located within the range from 2 until 4, right? So this is in means in 20s and 40s. So most of our data is in 20s and 40s, which means that most of the claims have taken from 20 to 40 days, means 20 until 40 days or 48 days to maximum, means within 20 to 40 days to complete the insurance claims. Okay, this is how we can have a relatively better understanding or visual of the data than in the table form. Table form does not give us any interpretable or convenient way of representation, but this one gives us much better than the table. Okay, now let's go towards box plot. This is another way of representing uh, data in a graphical form. Here it is called as box plot because it is represented as a box. So it is a box. We draw a box, and box has certain components to it, and it also has whiskers attached to it. These are called whiskers, which are connected with the box. This also mean something. It provides some information on each side, and box also provides an information. What information it provides is this one. The end of the whiskers on the left side and on the right side, I can means this not only the horizontal, it can be a vertical box plot also. Okay, so in that case the minimum will be on either top or bottom. So this end represents the minimum value in the data, or we find this value by this formula. I will tell you how we can use this one. And on the other side is the maximum value of the data, or we calculate this point using this formula. So in the box there is a median. Okay, there is a line that represents median of that data, and one end represents lower quartile or first quartile, and the other edge represents upper quartile or third quartile. Quartile means that quarter of the data. So if we talk about quarters, quarter means 1/4. There can be 4 quarters of the data. So first quarter means 25%, means the first quartile means that the data in the top 25% of the data distribution, and lower or third quartile means uh, and third quartile means the data in the third quarter or 75%, because if we divide into quarters, the first quarter is 25, second quarter is 50, third quarter is 75, and fourth quarter is 100. So this one is first quartile and this one is third quartile, means this edge represents third quartile and this edge represents first quartile, and the line inside the box, it can be in the middle or it can be towards Q3 or it can be towards Q1, okay, depending on the median of our data or the distribution of our data. But the line which is inside the box represents median, one edge of the box is first quartile of the data and other edge is third quartile of the data, and the length of the whisker goes until the minimum value and the other whisker goes to the maximum value of the data. So it can be either minimum or maximum value, or we choose to have it using this formula. Then after this, means once we have drawn it, we can also see data which are outliers. Outlier is the data which deviates too much from the original data distribution. Okay, the outliers can be beyond minimum or can be outside maximum values in this plot. Okay, so in this way we can find out and remove, because if the data is too much away from, like in the control chart, you know that if it goes outside of UCL or LCL, that is uncontrolled, that shows uncontrolled process. Similarly, this one is outside of our regular or our normal data distribution, so these are called outliers and we can reject them from our analysis. And this one, the length of this box plot is called as interquartile range. This is the range from Q1 until Q3. So it can be simply find out by subtracting Q1 from Q3, right? And using this one IQR, we can find out this value Q1. This is Q1, the value of Q1 minus 1.5 times of this one. Okay, so and the maximum one, this Q3 plus 1.5 times of this IQR. Okay, means that this is the length of the whisker is the distance from quartile 1 or quartile 3 by 1.5 times of QR. So this is 1.5 times QR. This length is 1.5 times QR. Now let's see these formulas. These are some of the characteristics of the box plot. Okay, now if we have because in order to plot the box plot, we need to find out median, right? So let us consider this is the data, very small data set that we have, and it has odd number of terms, means 1 2 3 4 5 6 7 8 9 and 10. So how many terms these are? 1 2 3 4 5 6 7 8 and 9. 9 is an odd number, right? So this is a data set that consists of odd number of terms. For this we can find out median by using this formula, n minus 1 over 2. Here n is the total number of terms in the data, so it has 9. So 9 minus 1 over 2 plus 1. It will give us the fifth term as the median. So this is the median in this data set. Okay, in this small data set we have this as the median. But if we have even number of terms instead of odd number of terms, Then we have to use a bit different way to find out median of that data set. Okay, the median is actually the middle part of the data around which equal number of data points exist. For example, if this is the median, there should be equal number of points on each side of this. This is the definition of median, that it lies right in the middle of the data. So if this is a median, on left side there are 1 2 3 and 4 points. There should be 4 points on the right side also, 1 2 3 and 4. Okay, exactly equal number of points on each side of the median. But if there are even number of terms, 1 2 3 4 5 6 7 and 8, like in this one, this even number of terms, we cannot find the median number here. If we consider this one as median, there are 4 points on the right side but 3 on the left. If you consider this one, there are 3 on the right and 4 on the left. So we have to use a bit different way of finding the median in the case when we have even number of terms. So it is calculated by taking the average of n over second, means n over 2th term, and n over 2 plus 1th terms. So which terms are these? N over 2th term is the term which is in the middle. If these are 8, 8 divided by 2 is the 4th term, 1 2 3 and 4. This is the n over 2th term, right? And which one is the n over 2 plus 1th term? The next one, n over 2 plus 1. This is n over 2 plus 1 is this term. So these are the n over 2th term and n over 2 plus 1th term. So we have to take its average. 5 is the n over 2th term and 6 is the n over 2 plus 1th term on next term. So we add them together, divide by 2, means it is the average of these two. It gives us 5.5. 5.5 lies in between these. Here is the median. Okay, so the median of these lie between n over 2, n over 2th term and n over 2 plus 1th term, in between here, like this. So that's how we can find out median to plot on the box plot. And for q1 and q3 we can find like this. The q first quartile is like this. This is first, because this is first, it should be 25%. 25% of the total data. If this one has let's say 8 values, this will be 8 and will be 8. If the previous one had 40 points, like the insurance claim applications, this will be 40. So 0.25 times n means 25%, or the first quartile of the data plus 0.5. This will give us the value for first quartile, and we will plot it on the left side of, on the left edge of the box. And the third quartile is like this. Third quartile is the 75%, right? 75% of the data plus 0.5. This is how we can find third quartile. Now we need to know IQR, interquartile range, which is simply by subtracting Q1 from Q3. So Q3 minus Q1 gives us interquartile range. Now maximum and minimum values are calculated like this. Q1 minus 1.5 times IQR, and the maximum one, Q3 plus 1.5 IQR, 1.5 times IQR. Okay, so like this we can have all the values which are required in order to plot a box plot. Now let us see an example. Now let us look at an example. Example is the same example from the previous data, that was the health insurance claims. This one has 40 values, 40 values in the data. The minimum one is 16 and the maximum is 56. So we can plot a box plot. It will look like this exactly. This is plotted using Microsoft Excel. You can also try. Now you see that this is actually its orientation is vertical. The one that I showed you before while explaining the box plot, that was horizontal. this one is vertical. We can draw them in both ways, either vertical or horizontal. So now this one is Q1 or quartile 1, this one is median, this one is quartile 3, and this one is minimum, and this one is maximum, and this one goes away, which is outlier. Now your job is to calculate these values using the formulas given in the slide before. Okay, so you should be able to find out this one. This is Q1, this is median, this is Q3, this is minimum, this is maximum, and this one is outlier because it is falling beyond this maximum value, which was calculated by adding 1.5 times IQR to this Q3, right? So you try to calculate these values and see if you can get these values or not. Now, a time series plot. This is a very simple one, and it is important because in processes, time is one of the very important factors of variance. Studying variance in the uh, manufacturing or a service process. We use the same data and we plot it, but this time the plot is with respect to time axis. We will study this data with respect to time, that how many days of the application, or how many days of the cycle were during the first few applications, and next few, and then next few, and then next few. This is how a time series plot looks like. Here at the bottom on the x-axis, it represents actually the time. The time means that present, past, and future. Like in claims, this is the number of the application, the first application, second application, third application, fifth, ninth, 13th, 17th, and so on. So this one represents the time of the applications, because the first applications were in the initial time of the when the data recording started, and the 40th when 35 until 40 were the last ones in the time. Like if we were measuring, if we were recording this data over 2 weeks time, so this was in the first week and this one was the second week of the data recording. That's why it is time based analysis. So on this one we can immediately see one thing, which is that the first 20, almost 20 or 21, these one took much longer time of this in order for completion, or they had these applications until 20. The first half of the applications uh, took much longer cycle time. They were completed in longer time than the last ones. So these are the number of days actually. So the higher these points are, the more time they have taken in order to get completed. Their cycle time was long. While on the other side, in the second half, from 21 until 40, the time is significantly smaller than as the ones which were in the starting. It means that there must have been something improved during the later part of the process. Maybe during first week of during of the data recording or the monitoring, they were experiencing some problems which they fixed during the next week, and they improved the cycle time of the insurance claims.